Welcome to Earthfeed, From Soil to Shelf, where packaging expert and yoga enthusiast Kelly Williams helps small and medium brands transition to sustainable packaging. This podcast is brought to you by Earth First Compostable Packaging Solutions.
Welcome to Earthfeed. So today we're going to talk about materials in motion. So I'm going to introduce my guests. We have Rahul Rasal from NatureWorks. Rahul Rasal is the Global VP of Commercial at NatureWorks. It's a world-leading company that invents and manufactures high-performing biopolymers and applications under the NGO name. We know you as polylactic acid. You were the pioneers in PLA polymers. In his current role, is responsible for global sales, marketing, product management. I think what's important about Rahul being on this call is he got his PhD in PLA and spent enough time outside of PLA in the polyolefins world that he brings a really nice perspective to that, all of the biopolymers that are out there. And then we have with us Paul Fowler from the University of Wisconsin-Stevens Point. He runs the institute there where they do compostability testing, they do research. What I like about Paul is he's got 30 years of really understanding cellulosics, the way we make cellulosics today, which 93% of the world's craft comes from, or pulp comes from the craft process. He understands that, but he also looks at cellulosics as a material to develop. So he gets involved in a lot of different application development, a lot of it tied to packaging. So he really brings a nice perspective to cellulosics that I think is very important historically and extrapolating that towards the future. And then we have Rick Stokes, the VP of the coatings group at Sun Chemical. I like the way Rick informally describes his role. If you don't know, Sun Chemical is the largest pigment producer in the world. So if there's an ink somewhere, Sun's probably involved in it. Rick handles everything non-pigmented. He handles all the colorless stuff. So the coatings, adhesives, and everything else. But Rick comes from a really, 30 plus years in adhesives and coatings. So he comes at this conversation around packaging from all of the stuff that goes on it, in it, glues it together. So I think today we have a really good mix of people who have a historical perspective on packaging materials. They could take our current state and let's start to see where we can go in the future. So I'll start with maybe Rahul, because Rahul, you have a nice background between polyolefins and PLA. So maybe you share your perspective on that same, overall mega trend of how we got here.
Yeah, thanks, Kelly. I'll spend a couple of minutes on my story. I came to the USA to do my PhD on sustainable materials, and that ended up being polylactic acid PLA, right? That was almost 2 decades ago. So I would say the first industrial material that I laid my hands on, and at the time being, it was for the research purpose, that was PLA. So I have some sort of like emotional bonding with PLA, right? You can relate with the fact that was the first industrial material I laid my hands on. And if I want to put my R&D hat, I still vividly remember the first experiment I ran with PLA was running a DSC on PLA pellets from NatureWorks. At the time being, NatureWorks was only serious and scalable producer of PLA, right? And now we have more producers, and that's a good thing for the industry, right? When we have multiple companies doing the same thing. And since then, I focus on various aspects of PLA, again, very fundamental structure property relationships type research at Clemson. And then I went on to work for 3M, where I switched gears and I worked on acrylics and fluorochemicals and so on, all R&D assignments. And I think my experience with ExxonMobil, where I started to wear a commercial hat, I went on the other side, right, at ExxonMobil. So that was my commercial experience. And by and large, most of my time at ExxonMobil, I focused on polyolefins and similar applications, right? We're talking about packaging, flexible packaging, rigid packaging. We're talking about non-ovens, hygiene, and so on. And now I'm coming back to NatureWorks, right? It's truly a 360-degree journey. And when NatureWorks called me for this role, it was an easy sell for me, right? I kind of wanted to reverse engineer my retirement speech, and I put myself into that shoes. And I was thinking like how cool that would be to say, I started my industrial journey with PLA, and after 2 decades, I got a call back from NatureWorks to lead the company through the current demand supply dynamic we have, and that's how I ended up with NatureWorks. So now I think getting back to your point, I know we talked about this earlier, and I think the PLA as a material class, right? It has right properties, right processing parameters, and again, there is some development that still needs to happen depending on the application. But given where it is today, and I know Kelly, you this is your code, but I'll borrow it. PLA has the right to be the ubiquitous material in packaging, both flexible and rigid packaging, and I truly believe that, right? So if you look at the properties profile, the processing, the track record, right? PLA has been trialed in various packaging applications, right? I remember when I was doing my PhD, we're talking about the snack bags from PepsiCo, right? They were trialing PLA at the time being. So given its the three things there, right? The structure, properties, and even the end of life benefits, right? With compostability and so on. I strongly believe PLA does have the right to be the ubiquitous material in packaging.
And so the part of PLA that I feel like gets lost a little bit is, what's it based on? Lactic acid. If we want to really stop and say, when you talk about building blocks, it's lactic acid. When we work out, our muscles turn glucose into lactic acid, and our livers turn it back into glucose. That's a pretty cool little circle, ain't it, for circularity? But it also manages the pH in our guts. It manages the pH in the soil. Like, lactic acid is ubiquitous and involved in many circularities of regulation, soil health, gut health, all these different things. And we preserve food with it. Come on, we preserve our food with lactic acid. Why not wrap it in polylactic acid? And I feel like after 20 years of polylactic acid being there, you realize, man, I can blow it. I can cast it. I can biaxially orient it. I can extrusion coat it. You can emulsify it to make coatings. It's a very ubiquitous material that doesn't get enough. But I feel like, how many people out there really understand polyolefin extrusion and biopolymer extrusion enough to say, yeah, this is some pretty cool stuff. So I feel like we're stuck behind we're just not talking about these things. So Rick, you've got some experience with PLA. How does Sun look at PLA as a material of the future?
Yeah, well, it's a very easy material to print and package, right? And our whole business is really supplying the inks, the coatings, and adhesive to help people put packages together. And PLA works in those processes ideally, right? So there's not a lot of, from the converter standpoint, a lot of equipment changes. There's not a lot that we have to do as far as performance to get our products to adhere to those substrates and to put that package together. Now, where it does make it a little bit difficult for us is that if we supply an ink, a coating, and adhesive that is not compostable friendly, then we're going to very much limit the life cycle of that product. So that's where we've had to completely redesign everything that we do. But as far as the processes, PLA is a great substrate for them.
From a large global chemical company, I feel like part of, like back in the 70s and 80s, chemical companies did basic research and discovery research. They went in, some of the materials we rely on to this day were discovered on sheer, hey, go create something new. We don't do that anymore.
I think the first step is recognizing you have a problem, right? And so, I've only been at Sun 7 years, but I'm fascinated by our history. So a couple inflection points, right? One was right at the end of the 18th century, Prince Albert Tobacco came to Sun Chemical and said, hey, can you come up with a red that we can paint our cans with, right? And so we were the red on the Prince Albert Tobacco cans. And that was one of the first, packaged commercial goods. So you go about 100 years past that and you look at our business model, and still about 80 to 90% of all the ink that we were selling was to publications, so newspapers, magazines, right? So not that long ago, Kelly already told everybody how old I am. So yeah, go back 30 years, and 10 years into that, Sun Chemical was still selling mostly into publications. Today, we sell 80 to 90% of our inks into packaging, right? So it's complete inflection change on what we do, and yet we're about the same size, right? So packaging has become our business, and now everything that we sell needs to be redesigned so it's at least it is sustainable, so we contribute to the life cycle, or at least don't inhibit the life cycle of those products. in that it needs to be compostable or recyclable, and that's causing a complete redesign. And we recognize it. So that's where our R&D dollars are going, is to make sure that we're contributing positively to this inflection.
And where do you go to find new? So you think about molecules, right? So, and this is actually a good segue for Paul.
So I'm pro tree, I have to say, and I'm pro fresh fiber. But if you look back pre-craft pulping, then hemp was the predominant source of fiber, at least in the United States, for making paper. The craft process came along, and everything sort of shifted towards the use of wood fiber for making paper, for the reasons that you outlined earlier, the dense nature of wood and so on, and the efficiency of the craft process in extracting or accessing that fiber. Just to kind of pick up on where Rahul left off, I started my career as a carbohydrate chemist, so glucose has been in my veins, both sort of professionally and literally, since the 90s. And I mean, it's there in everything that we do, right? From the point of view of making lactic acid, from the point of view of building cellulose, building starch-based thermoplastics, and so on. So I think the whole sort of cellulosics thing based on glucose, incredibly important from the point of view of renewability, and also important from the point of view of what else can you do in terms of accessing those molecules. And we've seen that trying to access new molecules, being innovative in that space, has just gotten more and more tricky as time has gone on, in terms of both the regulatory hurdles that we have to overcome, safety and so on, which are all correct. But to bring one new sort of polymer to market is a multi-decade endeavor, I think, these days. And NatureWorks is a great example of bringing PLA to market, but it's not been an easy ride, right? You look at polybutyl succinate, you look at the PHAs. I mean, it's been decades in the making. So I think we really have to make the most of what we have right now, and using cellulosics and fiber and substrates based on those, paperboard, just makes such an awful lot of sense in terms of circularity, in terms of reliability of supply, but then in terms of what you can do when you combine the best of both worlds in terms of performance and end of life. We had the invention of paper, 110 BC, by the Chinese. And that sort of innovation in terms of packaging has been there since prehistoric times, I would say, in terms of fiber use. And for me, the first sort of inflection point, I think, was probably, I go back to Carruthers and the invention of nylon, and just that whole sort of momentum that built around the petrochemical industry, nylon being a super material and so on. But that, for me, sort of starts to put the brakes on the use of fiber. And then you talked about sort of like the proliferation of polypropylene and polyethylene. But I think for me, the sort of origin story goes back to nylon. And maybe we see the advent of PLA and PHAs in the 70s, 80s, and so on. But really only on the extremes, if you like, of that sort of mainstream of what is happening in packaging. And I think not until 2017, I would say, Blue Planet 2 did the whole sort of story around plastics and the issues of plastics in the environment capture the world's attention on a global scale. And whilst folks were sort of tinkering at the edges in terms of paper, and we were doing a paper-based packaging conference back in 2012 before it was really trendy. But after 2017, I think things really started to take off, at least in terms of where the public perception were, and in terms of a mandate for folks to get really truly innovative in terms of both coatings and the use of laminates and coatings and the use of fiber as a substrate to carry those materials.
And that's what I've seen the same thing. In fact, I heard a new term that you may have even said this to me, the paperization of packaging, and we're seeing it. It is happening. But then it worries me too, because same with flexible packaging. So Rick will remember the statistic. In 2012, 17 converters of flexible packaging made up 64% of the market in North America. Today, in my estimate, that number is 10 and it's 86%.
It has hurt innovation. The little guy looking to break in with an innovative package or an innovative idea, there's just fewer of them, and that hurts.
What do you think, Rahul?
Yeah, I think I was gonna chime in on. We have cellulosic substrates, we have biopolymers like PLA, PH, and so on. And at a very high level, right? If you look at from the design perspective, like Rick was talking about, redesigning the new generation packaging, there is an and equation and there is an or equation. And let's be clear, right? There are gonna be some applications and sub applications where that or equation is there, right? Is it PLA or is it paper? And that's just the reality. But given the size of the industry and capacities and all, at least from the biopolymer standpoint, it's still a small industry compared with paper or olefins. And I strongly believe we really need to focus on that and equation, right? So I think Rick can attest to that. We're talking about coatings, right? And for Paul, there's a strong application for PLA coatings on paper, right? So it's a compostable packaging, right? So that's perfect example of and equation. And I think more and more these and equations we find out and leverage the synergies. I think that's going to be great for industry, because at the end of the day, not a single material has the capacity to be able to offer that sustainable alternative to the plastic pollution problem we have today, right? So I think that's where leveraging and that and equation is really important. And coatings is a perfect example, right? PLA is a compostable, goes on paper, and now you have a compostable packaging solution. Just one example. And I think if you look at the evolution of packaging materials, right, there are few key attributes, right, that's been the common denominator. One is the barrier, right? You need barrier for shelf life and so on. Other is the right modulus and processing and so on. And if you look at PLA, it does offer that, right? You talked about metallization. You can metallize PLA. You can get the right barrier. It has right modulus. It can have right transparency and so on. So overall, I think it's a pretty decent choice for some of the packaging applications, right? Probably not all of them, but most of the packaging applications.
Hey, I think that that ownership structure that Rick was talking about in the polyolefin industry, I mean, it's mirrored in the pulp and paper industry too. I mean, I would say since the 80s, consolidation, private equity companies buying up mills has really gone on at a significant sort of pace. And then you look at the sort of the timeframes that those companies are operating on, maybe 3 or 4 years, then that's a real barrier to innovation in those places. It's just churn, make the same product cheaper and with fewer people. And I think now there's starting to be a realization, and don't let me tar all companies with the same brush, but I think the realization that paper is a substrate on the one hand, but also as something which brings a functionality to a package is really starting to bite and sort of bring about some sort of a renaissance in R&D. And I think we sort of seeing more collaboration across the value chain as well, from converters and from brands as well, sort of driving that innovation. But there's still that sort of vexing question on who pays for it. But I think the conversation has shifted somewhat away from understanding that you can't just keep making the same products that you were making 20 years ago, because look globally about how the packaging landscape has changed, about how folks view sustainability. That has just changed completely in the space of a generation. And so if you want to move forward in that industry with cellulosics and really sort of start to tackle this huge opportunity that flexible or rigid packaging offers up in terms of that whole life cycle benefit, then you really have to be sort of playing in that innovation space and knowing whom else of that value chain make for great partners to be able to bring a project to market. And also understand that inventing a new molecule, as I said before, doesn't happen overnight, doesn't happen in a decade, or a new polymer. It's a long hard slog.
In flexible packaging, there's just been a deterioration of application development altogether because there hasn't needed to be. When there's only 10 cents a pound difference between 48 gauge polyester and 48 gauge metallized polyester, what more innovation are you going to extract from it? So we've over-engineered packaging, and retailers and brands know it's over-engineered, but it doesn't answer that fundamental question: what's good enough? What's good enough, right? So we have to know. I feel like today we now are starting to get real understanding of what that is, but there has to be an acceptance of a rethink. But where do you incubate it? Where do you try it? And you look at. So to me, it's about, if you look at decarbonization as a general trend, and getting food waste out of landfills and fixing our failing human gut biome, which is what compost is important. You can start to see that where physical industrial compost centers may be the future footprint of biorefineries, where we're doing these things, making lactic acid from food waste, extracting cellulosics from hemp and regional biomass. We can start to build these things in a different way, but it doesn't happen through the existing infrastructure because it was built on bioaccumulation not being considered in the overall design of it.
I will say, you said a dirty word though. You said infrastructure, right? And that word has become an excuse, right? It's become an excuse. Again, Rahul probably feels the same way. Like, we've got solutions sitting on the shelves ready to go for sustainable packaging, right? And the excuse we get downstream is, well, the infrastructure doesn't exist. There aren't enough compostable facilities. Well, I don't have a press that prints on paper today. I have presses that print on plastic, and I don't know how to adopt. I don't know how to make the switch, and I don't have the infrastructure. And it's frustrating. It's frustrating, right? Knowing that there are solutions out there, and yet the infrastructure is not there. But that's just time. That's just time. Like I said before, everybody was printing newspapers, 30 years ago, right? We're the same size. We sell just as much ink. Everybody's printing packaging today. That was an infrastructure switch. So it'll change. We'll catch up. But man, I hate hearing that as an excuse. I'd love to hear, we don't have the infrastructure today, and here's our plan to get the infrastructure in place. I think that's what we're missing. That would give the industry confidence, just knowing there's a plan to start adopting these things and start finding problems.
Yeah, there are two key themes that I heard from what Kelly said and what Rick said, right? One is decarbonization, and the other one is the infrastructure, and I think they are related. So if I take a high level view, decarbonization, when you look at compostable packaging, food diversion from landfill to compostable, right? That's a big value proposition for everything that's happening around decarbonization. I was stunned when I look at statistics, right? It's one of the leading sources for greenhouse gas emissions, right? Food waste in landfill or incineration. And we do have solutions, like Rick said, right? These solutions are sitting on our shelf. We've been looking into this for a while. They work. There is a premium that needs to be paid that comes with that innovation curve and where it sits in that innovation life cycle. And then how do we kind of tie that with the infrastructure, the theme that Rick touched upon, right? And I feel like those pieces are sitting out there, but the value chain players and industry needs to collaborate to come to some sort of like synergies to make it happen. There is a strong enough value proposition, and these dots just need to be connected for us to get there.
How do we get there on the cellulosic side, Paul? Do we need more mills? Do we need new ways of biomass fractionation? What do you think is the key to unlocking what I call intact, sustainable? I think Sun Chemical should use that word, sustainable. It's like, if it's intact, made by nature, we can use it either enzymatically or catalytically, thermally, whatever. How do we do it?
So I think we're at the tip of the iceberg in terms of the functionality that we can achieve by bringing the best of both worlds of renewable biopolymers and cellulosics together. I really do. And then in terms of additional processing that we can do with cellulosics themselves, whether it's nanocellulose, cellulose microfibrils, or just being smart about how we either laminate or coat or intermingle PLA with cellulose fibers in a paper making machine. I think the end of life bit we shouldn't underestimate. just such a huge opportunity there. I appreciate Rick's comments about infrastructure being a dirty word, but I do have a sense that the sort of the composting space is more susceptible now, or more receptive to the idea of accepting packaging as a vehicle for getting food waste into a composting system, not as a feedstock for making compost per se. I don't think that's a starter. But I think there is a momentum there now, and I think regulation is going to be part of that driver as well. We're seeing that happening at least on the coasts right now, and we're seeing it happening in Europe too. So I think we don't underestimate innovation, and we don't underestimate regulation either, from the point of view of the way that those two factors will drive that space forward. Do we need more mills? Right now, we've got a vastly underutilized wood resource in North America. We talked about printing newsprint earlier. The whole sort of dynamic in the use of fiber has changed. But if you look globally at fiber use, it's changed, but it's not really declining to any sort of significant extent. We're just making different things with that material. And I think what I would advocate for is a change of mindset in those major users of fiber, from the point of view of saying, okay, well, we can't continue to make the same old product. Companies have tried that, and they've disappeared. So we need to be nimble, innovative, and sort of move into those spaces where we see global customer demand for smart, sustainable packaging that's based on fiber. Really easy to say, I know that, but the market is there. That market is there, and I think sort of precipitated by what I said before about Blue Planet 2 and so on. But it's a trend that I don't think is going away. We need to continue to be absolutely rigorous in our science in terms of demonstrating performance in use, rigorous in our claims, have some foresight about what's happening in that regulatory space, but really sort of play to the strengths of, on the one hand, renewability from the point of view of sourcing, performance in use, and then the opportunities that come from end of life, whether it's composting or recycling.
I love everything you guys just said. I couldn't agree more. And I feel like pre-competitive collaboration, we are close enough to understanding what that means that maybe we can get around some of the application development. Basically, it's a lack of resources. No one does application development like this the way they used to, and now we need to do that more. But I want to go back to coatings, especially having you here, Paul, and Rick from Sun's perspective. So if you look at the history of packaging, where did it start? It started with PVDC coated cellophane and glassine coated paper. It worked. And then polypropylene comes along, and it was so thin and so pristine and so strong and just so perfect. And the moisture barrier was incredible. No oxygen barrier. It replaced cellophane pretty quickly. In fact, I used to use a bag of Doritos printed 1979. November 1979, they found off the coast of North Carolina. And that bag was at least some point in the ocean. It looked damn good after 47 years. That was the same year they stopped using cellophane and went to polypropylene.
Like you said, over-engineered, right?
Over-engineered. But the important thing is coatings. Coatings are incredibly important here, because coatings on natural materials is how you start to tailor enough functionality, whether it's barrier or sealing or whatever. You can start to augment the chassis to do these things, and you do that through green chemistry. So now, Sun, you have to go find intact polymers from nature to valorize, to formulate into that new drum of something. How do you do it?
Yeah, Kelly, it's collaboration, right? Like, again, we're the world's largest pigments company, and with that, we've become the world's largest ink company. And to create an ink, you have to put it in a carrier, or put the pigments into a carrier. We are dependent on our partners to come up with those innovative carriers. We do some of it ourselves. We do have some molecule benders in our labs, some polymer science guys, and they do a really nice job. But we are dependent on collaboration. And so the folks that are making those biomolecules, bringing them to us and seeing what we can do with them. to your point, it's, connecting the dots and going to the conferences and finding the Rahuls and the folks that we can collaborate with.
When people say scale, that's not scalable. How do you get people to realize that you don't build scale like that anymore? We have built these enormously long supply lines.
So I think the challenge is the regulatory space there. I mean, I think the effort that you go to for a 60-ton-a-day plant or a 300-ton-a-day plant is probably skewed in favor of the 300-ton-a-day plant, just because the regulatory burden is not going to be any significantly less, regardless of the scale. I think that's a sort of a real concern. I mean, and then the capital investment is still pretty significant, right? And then the other issue, I guess, is around quality. The ability to be able to make a product consistently when you're sourcing feedstocks regionally and processing them regionally, rather than in some sort of mega plant where the output is, on the face of it, going to be pretty consistent day after day after day. So I think challenges around getting all the regulatory stuff in place to build a plant in the first instance, and then about quality control when you have that sort of distributed model. And I think we're thinking about that in terms of composting right now, and the opportunities to mainstream the use of compost in mainstream agriculture. I mean, compost in agriculture has typically been artisanal, right? Organic, small scale, and so on. But you start to look at the availability of biomass, then there's a part of me that says, okay, well, there's probably enough biomass out there to start to do something in terms of conventional agriculture, meeting some of the regenerative agriculture goals by saying, okay, how do we get compost into mainstream in agriculture? And that means, how do you scale that? Is it a distributed model? Is it a centralized model? And then there are the same sort of pros and cons that come into play there in terms of, okay, actually getting the permission to site a plant in a place or several plants, and then, okay, how do you ensure that you have a consistency of supply, a quality that is the same day in, day out, that your customers have the confidence that they can use and know that it's going to behave in the same way day in, day out, every day?
Yeah, I was going to say, Kelly and Paul, I think this is such an interesting question that we face every day, right? I think we can relate with this. How do we get to the scale? And point number one is, as you all know clearly, that doesn't happen overnight. There are multiple pieces that need to fall in place, right? We're talking about the innovation at the molecular level, right? That's where it starts sometimes. Innovation in application development, and then innovation or trends in regulatory landscape, raw material supply chain, and all these things. They kind of have to come in place for a given product to build the scale. If you look at, let's say, polyolefins, right? It's an interesting data point when I look at when these materials started to get industrial, maybe in 50s and 60s, and how long it took for that scale to build up, right? If you look at a typical polypropylene or polyethylene plant, it's easily 400,000, 500,000 to 1,000 KTA, right? Kilotons per year. That's the scale. You look at a typical PLA plant, it can be anywhere from 60 to 150 KTA, right? Kilotons per year. And that's still tremendous, right? And that gives me optimism, because for PLA, this development happened over, like, let's say, a couple of decades, industrialization of PLA, versus for olefins, we're looking at like 5 to 7 decades, right? So if you look at that time scale, that gives you the optimism, right? The rate and pace of the innovation, adoption, and commercialization of PLA has been great. And I would like to hear some numbers from Paul and Rick for their respective fields, right? I can talk about PLA because that's the world I live in. Point number two is, at the bottom of this is really the economics, right? What's the value? And we all know, right, with compostables and paper or PLA or PH and so on, there's a strong value proposition, but I think there is a question mark, right? Who is going to pay the premium for the innovation, adoption, commercialization, and building that scale? And I think that's where, to Rick's earlier point, how do we collaborate with industry to come to a solution where we can coexist and pay that premium as an industry, right?
Yeah. Yeah, Rahul, Paul, those are really cool points. I will say I'm a little less worried about it. I think it'll come. I just don't know when, and I'm not very patient, so it is bugging me. I know it'll happen because some brand, whether it be large or small, is going to have some really cool, innovative packages out there, and it probably won't have the scale to go mainstream, but everybody's going to want it. And once that demand and that fad kind of hits, I think that's where we're going to start to get investment. We're still kind of waiting on that. But that being said, we track our sustainability projects and sales, and we might hit double-digit percentages of products that we're selling that are the product themselves is designed to be sustainable, or we're enabling a sustainable package. And that's pretty good considering we really weren't anywhere just a few years ago. So the fact that we're cracking that 10% in sales, meaning we're headed in the right direction. We are starting to hit infrastructure limitations, right? Whether it be the press or the company making the biopolymers. So we are running into some obstacles. But again, the pace is there. It's starting to grow. I know not everybody's hitting their 2025 targets, but it seems like everybody is still trying to hit them. This might not be 2025. So I think it'll come. But Kelly, like you said, if we can find ways to speed it up and make sure that investment is being made, I think I know I'm committed to it. So.
It's a step in the right direction.
Exactly. So, hey guys, this was a lot of fun. This is a topic that's near and dear to my heart. I feel like too many people are trying to extrapolate a future state in this industry. And I'm telling you, if you don't use the appropriate relative historical pieces, your extrapolation is not going to be accurate. You improve accuracy by looking at the historical pieces. And I think we got that started. If you want to do it again, we'd love to jump on another one with you guys. That was a lot of fun. So I really appreciate it. So thank you, Rahul, Paul, Rick. Appreciate it. Thank you.
Hey, you're welcome, Kelly. It was fun.
Okay, anytime.
This podcast is brought to you by Earth First Compostable Packaging Solutions.